Dear students, we are going to see chapter 11 of advanced routing and switching. So, in this chapter, we are going to see some of the features and technologies for the campus network. And initially, we start with the link layer discovery protocol. And this link layer discovery protocol is one of the layer 2 protocol, and it's very important to know that how the switch communicate, okay, and the connection reduction and other things will be efficiently monitored. Okay, so there are the previous protocol, which is CDP. Okay, CDP, which is built in with the Cisco routers, but LLDP is defined in IEEE 8021AB. Okay, it is the IEEE proprietary, and the CDP is Cisco proprietary. So both of them run at layer 2. Okay, both of them run at layer 2, so that it is mentioned here. Run at layer 2. Okay, data link layer. And what are the benefit of CDP? It's very lightweight and may contain Cisco specific information. It is because it is a Cisco proprietary, but it is highly customizable. Customizable means you can have any kind of modifications in the LLDP. Okay, so that we will see in the coming slides. Okay, so it is an industry standard protocol for neighbor discovery. Okay, so mainly it is used for neighbor discovery, in the sense the neighbor protocol, what switches, what devices running in the neighbor, okay, network, okay, or connected devices. If it is unknown to the connecting device, then it will be easy for to detect. So that is the main point, which the main thing is neighbor discovery. So this slide, we understand that it is very important for the neighbor discovery, and also there is a comparison between CDP and LLDP. CDP is a Cisco proprietary. LLDP is defined as IEEE 8021AB. That is industry standard. Yes. Yeah. So the introduction of we coming to the introduction to the LLDP. It is, this protocol can advertise details such as configuration information, device capabilities, IP address, host name, and device identity. That is normally does by CDP also. Okay, CDP also does the same. Okay, and but more than that, it can be customizable. Okay, so LLDP is used for, okay, surplus plethora of information sharing. It is not architected to send real-time information such as performance data or counter data. Okay, so it is just used to detect the link, and to know that what are the neighbor device and their information, connectivity information, and the interface information, IP address, MAC address. Okay, all those things will be easily identified. So normally these protocols should be disabled for the security reason. Okay, so what is the advantage of LLDP over CDP is that it allows customization, that we see in the previous slide also. Okay, LLDP can carry a lot of information that is relevant to your network. What is a drawback? Okay, in comparison to CDP, it is not very lightweight. Lightweight means what? It has to run a lot of process, so it need more CPU time and other area that need to gather information to send to the neighbor device. That is the only reason we say that this is not very lightweight. Okay, and this is the following list of captures, okay, or details, implementation properties of LLDP. So what are they? It is a unidirectional, so one way detection, one way. Okay, one way detection. So it means that there will not be any loop created by LLDP. So, and LLDP operates only in an advertising mode. Okay, it means that sent advertising mode. Okay, it's not receiving or something written back. LLDP does not solicit for information or monitor state changes between LLDP nodes. And this is the layer 2, leverages layer 2 multicast frame to notify neighbors and itself and its properties. Right. And also it will receive and record all information, okay, about neighbors. That is by default, it knows that. And it uses two important multicast MAC address, okay, as the destination. Okay, so to find the details, so that it can just directly advertise, and also it is unidirectional, right? So if you come to the LLDP, the system name, okay, the system name and description, okay, these are the various detail we get it actually. List, okay, list of information exchanged with the campus switches. So it means that it gives detail of system name, port name, description, port VLAN, management IP address, system capabilities, that's very important to know about it, and power over Ethernet link aggregation. So the details received by okay, not by, from neighbors. Okay. What are the key features? LLDP allows network management applications to automatically discover and learn about the network devices. Yes, once you enable, so the detail will be ready automatically. Discover and learn. Okay, and it is an industry standard. That's we are discussing again and again. Okay, it supports enabling or disabling either transmitting or receiving capabilities per port. Okay, what is capability? We see before. What are the capabilities? Whether it is Wi-Fi, routing, switching, all those things. So if you know that a device, we find a device and that is capabilities, routing means or forwarding means, it means that it is a router device. If the device is a layer 2, it has to, we can easily identify that the capability switch, its STP function and other area like the VLAN, okay, which is enabled in the switches. So what are the switch property? We can just easily identify those devices are switch based devices. Okay, so switch, it's you can easily identify the capability. So it's very important to know the capabilities of, okay, easily identify per port. Okay, per port we can easily identify. So the port which is connected to that particular device, if that device is enabled with the LLDP, that can easily identify the neighbor, whether it is switch or router. Okay, that is the main. Okay, let's see that what is UDLD. Okay, UDLD, unidirectional link detection. It is one way. Okay, UDLD is what? One way. Okay, so this UDLD link occurs when traffic is transmitted between neighbors in one direction only. Okay, one direction only. Okay, one direction only. So most layer 1 mechanisms built into the Ethernet specification detect this connection and either prevent the link from ever establishing or bring the link up. However, in some situation, layer 1 may be operating correctly from link level, but at layer 2 traffic is unidirectional. Okay, layer 2 traffic is unidirectional. So that is very important to know about these cases. Okay, so you see that this is 3 switches connected and UDLD is one direction. So echo means what? The port configured with UDLD sends UDLD frames if it receives echo link functional bidirectional. It means that the UDLD is something which is not applicable. Okay, no response to UDLD packets means unidirectional. Okay, the switch is unidirectional. So the switch is working on unidirectional. So no response. Okay, this is very important to the UDLD packet. So it means that whenever the UDLD is functional, that we will be able to understand that switch is working on unidirectional. So the malfunction TX, soft switch 2. Okay. So it's very clear that the unidirectional condition, okay, at layer 2 is disastrous for any network because it will lead to the spanning tree not blocking on a forwarding port or a routing black hole. It means that it will keep going on, okay, in unidirectional. So if you don't receive echo, it means that it will be keep going on, okay, and we never get the signal back. It means that we never know where the signal or the packets end up, okay. In either of these situations, the network will exhibit a total failure, become unstable, and eventually create a complete loss of connectivity for the end users. So, what are the benefit actually? May protect the network from the following problem. Okay, transient hardware condition, hardware failure, and anomalous behavior of failures. Okay, so it means that you have to have the condition which is unknown. Okay, condition with layer 2 adversely operating or mostly anomalous condition. So this is very important example. The Cisco switch is designed with the utmost resilience, but it is possible that the transient hardware failure may lead to the described condition. It means that you have to just make over that the UDLD's functions, and if that device is not replying with any echo condition, it means that the device is failure, okay. And there is no such return back. It means then it will be going to the loop, black hole like looping, and never return any condition. So that's the main idea. We use UDLD to make the switches functional in a proper direction, and as well as it makes sure that we have the proper connectivity between the neighbors, okay. So optic or gigabit interface, okay, anomalous behavior, and also that interface converter, okay, gigabit interface converter is a transceiver that converts electric current, digital high and okay lows of optical signal. So, and miswired configuration, okay, that also it will be protecting. Okay, this is very important. We are seeing that what are the benefit of this, okay. May protect, okay, miswired cabling, software defect and condition, misconfigured malfunction in line, okay, tap or sniffer, okay. So what is the mechanism it uses? Okay, UDLD mechanism is specific, okay. UDLD mechanism is very specific, that UDLD supports all current switches, catalyst and nexus switches. So it runs on all the switches because it is a industry standard, okay, industry standard, okay, industry standard, okay, industry standard one, okay. So UDLD function transmitting layer 2 packets, well known MAC address, okay. This is the MAC address used for transmitting, so that UDLD packet is very clearly identified using this MAC address. If the packets are not echoed back, okay, returned back within a specific time frame, the link is flagged unidirectional. So device on both ends in the link must support UDLD protocol to successfully identify and disable unidirectional link. Okay, so it is sent to a regular interval. Okay, this timer can be modified. Default settings varies between platforms. So this is the regular interval. We have to send this unidirectional packet. Okay, unidirectional link detection packet, so that we can understand that neighbor is alive. Okay, what are the behavior? Normal mode behavior, aggressive mode behavior. There are modes of behavior. Okay, so the behavior of UDLD after it detects a unidirectional link is dependent on its operation mode, either normal mode or aggressive mode. These modes are normal mode, aggressive mode. What is the normal mode? When a unidirectional link is detected, the port is allowed to continue its operation. So unidirectional just marks a port having an undetermined state. It means that it's not going to end up. It means that going into a black hole, like a syslog message is generated, just notifying. Aggressive mode is what? When a unidirectional link is detected, the switch tries to re-establish a link. It sends one message a second for 8 seconds. If none of the messages are sent back, the port is placed error disabled state. It means that, so these two ports is just a notification. Notification will be sent back that the particular port is not functional, right? Okay, then we have a loop guard and UDLD functionality comparisons. So loop guard is what? What is loop guard? Loop guard is will ensure that if your blocked interface no longer receives PPDU, okay, bridge, okay, packet data unit from other side, that it will be shut down to prevent layer 2 loop. It means that loop guard, loop means what? Circling, okay, mukarrar, again and again in the same loop, same way it will be communicating. So it means that the other traffic will not be allowed. So we want to make sure that the loop guard must be enabled in order to prevent the loop in the layer 2 switches. So that is the main point. Once again, loop guard will ensure that if a blocked interface no longer receives PPDU. PPDU means what? Bridge packet data unit, that will be making the port state in a stable condition. From the other side, that it will be shut down to prevent layer loop. And also loop guard and UDLD, okay, loop guard and UDLD are two ways to protect your fiber cables from causing loops, okay, causing loops in the network. In short, loop guard is a spanning tree optimization. Optimization means what? Bringing to the normal level, okay. And UDLD is a layer, okay, layer 1 and layer 2 protocol related to spanning tree, that protects user upper layer protocols from causing loops in the network. So what are the various kind of difference between loop guard and UDLD? So configuration granularity, it means that it is the loop guard work per VLAN, UDLD work per port. You know, it's very clear. The port wise UDLD will check. Loop guard will check per VLAN, because the STP PPDU works on bridge, protocol works on VLAN. Protection against STP failures caused by unidirectional links. Yes, when enabled on all non-designated ports in a redundant topology, and then it will be enabled when enabled on all port in the topology. It means that all the ports, okay, all the ports in the topology will be enabled. And also whether it is loop guard, whether it is protecting against STP failure, yes, okay, resulting the switch not sending bridge protocol. But UDLD, it's not protecting, but it is just to concentrate on the port only. Clear? Okay. Next, come to the power over Ethernet. This is a well-known concept. You know very well. It's not much explanation required. You must have studied in the previous subject chapters, and it's more of power over Ethernet. You are going to consider. It's one of the important area that you need to consider for the cable itself having a power that enables the device on, keep on, the device will be keep on. It means that the minimum power required to enable the device, that is allowed in the power over Ethernet, the Ethernet cable itself, okay, supplies power through the same cable as data. So the power and the data into the same cable. So we can say the same cable having the, okay, power over Ethernet. So you can have all the switches. Your regular switches can be connected, okay, power injector you need, an IP phone power, okay. So all this has been just to data and power on in one cable. So this means that regular switches need power. The power over cable switch no need to have the power. So it means that the IP phone is connected with the switch. It means that that automatically enabled, okay. This is PoE, okay. So the difference is what? You need to have the switch to be connected to the power, and then the switch will take over the other devices that is connected into the devices, okay, power over Ethernet. So what are the benefits? Very important: remote management, okay, where power adapter is injected to not. And also switches allow centralized methods on backup power, okay, and require less configuration than the local power adapter and injector. And leverages data cabling infrastructure. No additional power cable is required with the case with the power adapter or injector. Still, the Cisco recommends you must have that uninterruptible backup supply in order to go on keep working with the devices, okay, continuously. Okay, it means that once the power is gone, the backup source, when developing PoE such an uninterruptible backup supply is needed. So otherwise, without backup power, in the case of power failure, it's a total power failure, the switch also will go. So we need to have a backup at least for the switches. So what are the components it's required? Okay, it's an important terminology. Okay, this may be the MCQ questions, you can just refer. Okay, power source, it is the, okay, switches and power injector. Power devices, what are the devices? Were camera, phone, access point, thin client, sensors, wall clock, and so on. So these are the various 1, 2, 3, 4, 5, 6. So these are the various devices can be powered using the PoE facility. As with the standard Ethernet, the distance of PoE is limited to 100 meters with the category 5 cable. So that is another example for how much the PoE can lead to the device power. What are the different standard? 8023AF, okay, that is used here, and 8023 at ratified 2019. So that is different kind of thing. So 802.3 AF, it's something like it allows up to 15.4 watt DC power, okay, available for each power devices. But here if you see that 3AF standard can provide power for 25 watt, and this number can be increased to 50 watt and more with implementation that are outside the standard. This standard also PoE plus, okay, or PoE plus. So this is the different standard based on the power difference, okay, power difference. So it means that this is 15.4 and this is, okay, 25, okay, up to 25, and also to 50 watt. What is negotiation happening? How the negotiation happening? The Cisco switches do not supply power to the port unless it specifically detects a need by the end device. This prevents the wasting of unnecessary power and so on. Okay, so these two various category switches tries to detect power, okay, and supplying a small voltage across a Ethernet cable. The switch then measures the resistance. If the measured resistance 25k ohm, then a power device is present. So, okay, this is negotiation. Negotiation means if power need, question mark. Okay, the power device can provide the switch with the power class information. The default class is 0 if the switch, the power device does not support power class discovery. So this is the very important point. So various kind of classes available, okay, minimum power which is needed here, okay, power classes. Okay, if you measure the power class, by default 14.4 default class, 4 volt for optional class, and 7 volt again optional, 15.4 optional. So if the power class is defined in the interface. So 51 watt valid, okay, it's a latest one, okay, it's a PoE plus. So next come to the point of SDM templates. SDM templates also, it's one of the important point, that switch database manager. Okay, SDM means what? Switch, okay, database DB manager. Okay, DB manager. What is the use of this database templates on specific access layer switches? So it's very important. It manages how layer 2 switches, okay, layer 2 and layer 3 switching information is maintained in the ternary content address memory, TCAM, and CAM also, okay, content addressable memory. So if different Cisco SDM templates are used for optimal use of system resources for specific features or feature set combination. Although the default SDM is configured for optimal use of all features simultaneously, SDM may be tweaked for those corner case specific scenario. So it means template means what? That can be used for a kind of a support. Okay, so it can be used in many places. Change CDF SDM template describes precautions to take changing the SDM template. So let's see what is SDM template going on. So we use in many places like templates modify system resources such as CAM and TCAM. CAM is what? Content addressable memory. TCAM is ternary content addressable memory. It is a Cisco built-in memory table, okay, address table that will be used for communicating across the switches. So that maintained by the switch itself. So what is a default templates? Default template, the template provides mix of unicast root, connected and host roots. Okay, and then routing templates. One example, you would enable this template if the device is performing routing in the distribution distribution and core of the network. So the layers, okay, distribution layer and core layer of the network. The device is able to carry numerous routes, but only for IP version 4. Access layer, it is that you would enable this template if you have many VLANs instance. This template reduces the resources that are allocated to the routing. So this is kind of VLAN, it's end point devices or the users that at end edge devices. And then VLAN and IP version 6, IP version 4. So these are the various area also this is communicated. Like VLAN is when you enable this template, you allocate most table space layer to unicast. You would use this when you have large subnet with many MAC addresses. That is also very important, that this template. So you see that there are a lot of templates are used: default templates, routing access templates, and then VLAN templates, and then you can use IP version 4 and IP version 6 dual if you want to turn on the IP version 6 capabilities of the device. When enabling this template, you have to choose between default routing and VLAN. Okay, what is default in the inside the IP version 4 and IP version 6? More space is reserved for IP version 6 routing and security. There is less reserved space for layer 2 unicast. Routing, more space is reserved for IP version 6. Okay, IP version 6 and routing than IP version. So it is more on IPv6. Okay, and suitable for when you are running dual stack environment with a lot of VLANs. Okay, you know that this template means you can just temporarily you can use those cases and accommodate a group of um, functionalities like VLANs and routing and access and IP version 4 and IP version 6 template. So it means that it leverages the functionality depends on the template you use it. Okay, so template, you can example, you can say Microsoft templates. Okay, like Microsoft Word, if you go, you can use the existing template means it's a pre-formatted container, we can say. So next come to the monitoring features, that is span. Okay, port analysis. Okay, port analysis, switch port analyzer. Okay, switch port analyzer, that's very important point you need to understand here. The switch port analyzer, that is the use of kind of things we need to understand where the packet goes. Okay, whenever there is an attack, okay, and whenever there is a traffic is more coming on a particular device, we can easily understand. Okay, span and remote span. Okay, or means remote. Okay, or means remote. Or means remote. Span session, an association of destination port with source ports. Source VLAN monitor in the traffic analysis. So it is like PC1 and PC2 communicates, but sniffer come in between, so that need to be monitored. Okay, so this is very important, that it is also connected that switch network, but we need to analyze whether they are a sniffer or not, the normal port conditions. So span terminology, which is ingress, egress. Okay, ingress means coming inside, egress going outside. Okay, and then destination port, that port which is always connected with the sniffer. Okay, so remote span, which has Okay, remote span support source and destination from different switches. Different switches. Span support same switches. So that is the difference between. So if you go into back to the same switches, okay, same switch, okay, remote span different switches, okay, different switches. Different switches, okay. So that is different cases. Here the VLAN concept also applicable, okay, that you can see through the picture. It's very clear. Okay, so RSpan in terms of configuration, RSpan consisting of the following, and that is very clear that the RSpan source session or RSpan VLAN, RSpan destination session that can be configured. Okay, so span configuration is just a switch port analyzer, and that just particularly within the switch, okay, same switch, the number of destination port is platform dependent. Some platform allows for more than one destination. Destination ports do not act as a normal port and do not participate in the spanning tree and so on. So normal traffic flows through the destination. Be careful not connect to any besides and device to a span destination port. So this is very important. You must be very careful of communicating with them. Then come to the IPSLA. Okay, these are the various features of the switch we are just covering up. Okay, here we are just pointing out completion of this section. You will understand the following basic use of IP SLA. Okay, service level agreement. SLA means what? Service. Okay, service level agreement. Okay, agreement. So basic example of ICMP IP SLA configuration and UDP configuration. So SLA is something you need to contract between the network provider and its customer. Okay, this is very important to know where you will be providing, okay, a form of guarantee to customer about level of user experience. So it's very important to know that you must have kind of support. Okay, otherwise it will be the customer will be facing lot of error. Okay, lot of error in the lot of error means a lot of quality of service problems. Okay, so the service provider must maintain the service level agreement. It is the agreement between the network provider and the customer. Okay, network provider and the customer. So that is very clearly mentioned here. Okay, if you see that it's a contract between the network provider and its customer. So it's very important. They have to manage this kind of service level agreement, so that they can easily consider it's one of the important part. Okay, so that it will be very easy for us. So SLA may contain specific about connectivity and performance agreements. Okay, so it is very clear that if you have 4 kilobytes or megabytes speed, the customer must have the performance of 4 kilobytes 4 megabytes or kilobytes speed in the internet, which is provided by the Omantel or any connection. Okay, so SLA typically outlines the minimum level of service and expected level of services. So SLA can also be used to basic planning budget. Okay, justify. For example, you are using 20 real connection, 25 real connection. So based on that, 4 Mbps. Okay, and 25 means you have a 10 Mbps connections. Okay, example. Okay, so overall IPSLA feature provides real-time feedback that network reachability. So this is very important for IPSLA, and also provides feedback necessary to ensure the network can sustain reliability application, mission critical applications such as web portal or ordering. Okay, what is the additional use of this? So edge to edge network availability monitoring, network performance monitoring, visibility like jitter, delay, all those things. And voice over IP, video, virtual private network monitoring, SLA monitoring, IP service network health, MPLS network monitoring, troubleshooting and network operations. Okay. So there is a simple concept like source and responder. Okay, source and responder, it means that source is the Cisco iOS device that sends probe packets, which is whether the device is exactly working or not working. Okay, so the destination probe may be another Cisco device, another network target such as web server or IP host. Okay, so that will respond, that is a responder. Okay, the responder, the destination majority test can be any IP device measurement accuracy of the sum of the test can be improved with an IPSLA responder. Responder is a device that runs on Cisco iOS software. So the responder add timestamp to the packet sent to the IPSLA. Source can take into account any latency, okay, any latency that occurs while the responder processing the test packets. For this test work properly, both source and responder clock needs to be synchronized through the NTP protocol. So this is one of the important point you need to understand. Okay, there is a source and responder, both are working on Cisco iOS devices and they will be getting the feedback from the devices that is mentioned here in the in the destination probe means what, to identify anything outside, okay, or detecting another Cisco device, okay, or such as web server or IP host. So this is the planning of the cases, like, okay, when the IPSL is source and responder, so both are iOS devices. Okay, iOS devices, they send the control message ask receiver at port 2020 on UDP, and then reply with the says OK. Once it's OK with the UDP 1967, and it means that probing base will be keep communicating with them and start listening UDP 2020, so that the communication to the source and the destination will be perfectly combined. So the operation and its responder will be finding out the latency between the source device and the destination device, and they can easily identify where the problem occurs. So this is where the latency will be identified here. T1 time is marked from 0 in milliseconds for simplicity. RTT is a round time, okay, okay, round table trip, actually time trip, actually. That is the case that we will use for responding from one layer to another layer. Okay, so the trip taken from T5, okay, T5 and to reach T2, okay, reach T2. So where, what, how much time it will take. Okay, this is the formula we use is, okay, RTT equal to T5 minus T5 minus T4, T5 and T3 minus T2. So 1.5 is what, the milliseconds T5, and T4 is what, 1.3. So that is the substitution we made here, T5 and minus T5 of minus, okay, of minus T5 of minus T4, T4, okay, and then that's the substitution, the value T4, and then T3 value is what we have. T3 is kind of yeah, 0.7, okay, T3 0.7, and then we come to T2 0.5. So if you calculate, you get 1.1 milliseconds. So this is a timestamp that from source to responder, okay, source to responder, how this will be communicated. Okay, timestamp. So elapsed time, okay, elapsed time. So with this, we just to conclude this lesson, okay, this lesson, and if you have any doubts, you can ask your teacher. Okay, thank you very much.